Well, class, welcome back to today's lesson. Today we're talking about parallel lines and proportional parts. But before we do that, let's recap the triangle proportionality theorem. The triangle proportionality theorem states if a line is parallel to a side of a triangle and intersects the other two sides. So for example, if we have AB is parallel to CD. AB parallel to CD and intersects the other two sides, then it divides the sides into segments of proportional lengths. So let's call this vertex E. So if AB is parallel to CD, then we know that EC to CA would be equal to ED over DB. As an example of that, we can look at right here. Let's say that we have the triangle. We know that the line is parallel, and we're asked to solve for x, given that 8, we have, let's call this 16, and this 12. So in order to solve for x, we're going to say x over 8 is equal to 16 over 12. We're going to do our cross products. 12x is equal to 8 times 16. So 12x would equal 8 times 16 is 128. And then we divide by 12. Now, if we're using a calculator, we get a decimal of 10.66 repeating. We do not like repeating decimals, so we would just simply reduce and say that x is equal to, if we reduced it by 2, we have 64 over 6, 32 over 3, 32 over 3. I know that's sort of hard to watch and apologize. So now let's extend this just a little bit. Let's take, for instance, parallel lines and proportional parts. If 3 or more parallel lines intersect two transversals, then they cut the transversals proportionally. So as the example, if AB is parallel to CD and parallel to EF, then we have the following proportion. AC, this segment here, to CE, this segment here, would be equal to BD over DF. Notice that nothing really changes. I like to look at it in this way. If I had a triangle, parallel line, and my third parallel line actually went through the vertex, notice the relationship here. So the parallel lines and proportional parts talks about if 3 or more parallel lines intersect two transversals, then they cut off the transversal proportionally. So let's do a couple examples. Example number 10. So we have the 3 parallel lines here, here, and here. So therefore, it's going to divide them proportionally. 45 to 18 would equal 52 to x. That gives us 45x is equal to, as the cross product, 936. So by division, x equals 20.8. Okay, example number 11. Parallel lines cut by two transversals. Therefore, I'm going to say 12 over 30 would equal 14 over x. Cross products, 12x is equal to 420 x equals 35. Example 12, very similar, except we have to take it a step further. Notice that here, once again, parallel lines, 32 represents the whole segment. So we need to know our segment here, which would be 32 minus 18. 32 minus 18 is 14. So now we have the proportion of 27x, or 27 over x, is equal 18 over 14. Apologize. My writing is horrible. So that's 18x equals 27 times 14, 378. Divide by 18, x equals 21. Number 13. Once again, we need to find the difference here for this segment. 92 minus 28 gives us 64. So I'm going to say 28 over 64 is equal to 31.5 over x. 28x is equal to 64 times 31.5, 2016. Divide both sides by 28, x equals 72. Now let's do a little bit with binomials. Still the same concept. These two are proportional to these two because we have parallel lines. We will have 24 over 18 is equal to 3x plus 1 over 12. Now, if you would like, you may reduce that before you actually start doing any operations. 6 goes into both of those, so it'd be 4 over 3. So that gives us 3 times 3x plus 1 is equal to 4 times 12. 9x plus 3 equals 48. 9x equals 45. So x equals 5 in this case. And last but not least, number 15. We're going to have, once again, parallel lines cut by 2 transversals. So 2x plus 2 over 21 would equal x plus 3 over 12. No simplification as far as cancellation, so our cross products. So we're going to say 12 times 2x plus 2 is equal to 21 times x plus 3. Cleaning those up, we get 24x plus 24 is equal to 21x plus 63. Combining like terms, 3x equals 39, where x equals 13. And there you have it. We have parallel lines and proportional parts. So, after looking at this lesson, please, if there's something that you do not catch on of, rewind it, take a look at it again, and you can begin your practice and your homework for this section.